Hello, this is Miss Chambers, and I am going to help you find the rotational symmetry of a regular polygon. So to start with, I'm going to read off the definition of rotational symmetry straight out of your textbook. It says if a figure can be rotated less than 360 degrees about a point so that the image and the pre-image are indistinguishable, the figure has rotational symmetry. So what I have here is I have my image, the green hexagon, and I know it's the pre-image because it doesn't have a prime symbol. And then the blue hexagon would be my image because it has the prime symbol. So according to this definition, if I can map my image onto my pre-image and then rotate it about a point, so let's rotate it about the center of the hexagon, and I'm going to read it off again, so that the image and the pre-image are indistinguishable. So I have rotated it, and that pre-image just about disappears behind that image. So that means that since the two are indistinguishable, that this regular hexagon has rotational symmetry. What you're going to be asked to do in your textbook, on worksheets, on quizzes, on tests, is to find what the rotational symmetry is. What that means is they want to know the degree measure of the turn that you made to make the pre-image and the image indistinguishable from each other. So in order to do that, we are going to use what we know about full circles and what we know about pie, as in apple pie, because we are going to cut, so to speak, this hexagon into pie pieces. So technically speaking, what I would be doing is I would be connecting opposite angles with line segments in a way that divides up my hexagon into 6 triangles, 6 congruent triangles. And the idea is, let me just group this, the idea is a full turn would be 360. And each of these are equivalent angles. They're congruent angles. Their measures are equivalent. So if a full turn's 360, then I could take 360 and divide it by 6 to find out what each of these angle measures would be. So I'm going to use my calculator. 360 divided by 6. I hope you can do that in your head, but just in case, here it is in the calculator. 60 degrees. So each of these angle measures would be 60 degrees. So that means that if I turn or rotate my image so that A prime would map onto the next vertex, that would make them consecutive. So if it maps onto the next vertex, if I make that turn, that would be a 60-degree turn. So one turn using the sides as my guide for matching up would be 60 degrees. So the rotational symmetry of this hexagon, and we can see that this pattern is going to continue, but the first one would be 60 degrees. Okay? And then if I turn it again, that wouldn't be 60 degrees, that would be a full 60 plus 60 from the original starting point. So that would be 120. And then we continue around. So the next turn would be 180, 240, and 300. 80, 240, and 300. So using that system, I can easily find the angle of rotation because it's a regular polygon.